Second, yeah, this should be okay. So, hey, welcome. Thank you for inviting me, Hubert. And the session is Let It Snow in the Summer. This is going to be a quickly session. Quick because I have a lot of materials over 3 slides and something more and demos. So yeah, the speed should be quite of a big pace. Now, I'm talking as a SQL Server guys, so I'm going to compare Snowflake to SQL at some point, especially in these places where SQL is somewhere not ahead Snowflake, so where you can get some gains from Snowflake. So now, a few words about me, if my screen allows me to. Sorry, freezes. Yeah. So I'm a CTO at Elitmind. That's a Snowflake's partner as well as Microsoft's partner. We are Snowflake's partner start of today. Well, perhaps that's why I'm here. I'm also a founder of something historically called Polish SQL Server User Group, which is called now Data Community Poland, and you're here. So I started this user group actually. I'm a Microsoft MVP in data platform area, previously in SQL Server. I'm also cloud enthusiast, dealing with some big data challenges, especially from the architectural perspective. I have a blog which is quite dead, but I promise every single year to blog something, so be patient. But also I'm a family man, so you may expect my wife's acceptance factor to, get down at this moment. And I'm a quite avid runner, so if you run, we have some common topics. Now, why this session? First of all, I started to look at Snowflake as a platform for data warehousing probably like a year and a half ago. But this chart comes from October last year, and this is first wave on data warehousing in the cloud, particularly in the cloud. And you can see, probably you can see, that here, besides AWS, which is an obvious leader because of Redshift as a first cloud-delivered data warehouse platform, we see Snowflake, which is not that big as AWS or maybe Microsoft as well, but it's solidly growing. And it's definitely in the leaders. So I started to think, what the heck is Snowflake, right? I have to have my hands dirty with Snowflake because otherwise I'm not sure with what I'm fighting with Microsoft stack, right? So I started to play with Snowflake, and then a bit further we had this Gartner quadrant on data management for analytics system, where Snowflake was the only one who moved from niche players to, from challengers actually, no, from niche players to leaders in 1 year. Does anybody know what was the difference on the previous year besides Snowflake in the leaders? Well, actually, some of the companies were here. For example, Cloudera was here in challengers, but it fell to niche players because they are not able to execute. And also, some big vendors dropped, like Teradata. So at some point, it's Snowflake's fault because they are gaining business because of migration from Teradata, Netezza, and big NPP systems. So that was actually my go-to action point in history. So this year, January, when this Gartner showed up, I decided to involve myself in Snowflake a bit more. So I'm a quite young Snowflake apprentice, you may say. Now, disclaimers. Some of the slides are taken from official slide decks from Snowflake. Thank you. This is not a sponsored session, so I have my right to share with you some opinions, my opinions, like where Snowflake has its caveats, may have, but also I will share some good news, where it's very strong platform as well. This is going to be only on Azure, so if you're expecting me to show you some AWS fancy stuff, it's not this session. And this session is definitely not about data warehousing as data warehousing methodologies. I'm not going to say a word about Kimball, Data Vault, and stuff related to modeling, right? I'm going to show you the product and its features, and you may consume it and on your own decide whether it's a good platform for your data warehouse or not. So this is not going to be an advertisement, I hope so. Now, the agenda is pretty long. I'm going to start with concepts and architecture, then I move to ETL, showing some sample demo. Then I will move to unique features, things that I think are unique in Snowflake. Then I will show you some of the SQL Surface also unique things from SQL Server guy's perspective. I will discuss cost management, how to manage this actually. Then I will move to business stuff like what editions of Snowflake you can choose, what is the pricing, and maybe I will also encourage you to discuss pricing with the guys of Snowflake here. And then I will present you with some of the resources that you can use to learn Snowflake on your own. So quickly, some of the marketing slides. We know all that we have big data problem. Yes, this is big data problem, many data sources, many data, lots of that. Now, this is a not very obvious problem. Yes, we are not able, with historical platforms, we are not able to scale easily. Either we have a single machine installations, SQL Server, or we have complex MPP installations with their caveats, like problems with concurrency, problems with I don't know, maybe even scalability, because at some point, if you look at the cloud PaaS services, you may experience lots of problems with scalability, with scaling up, scaling down, scaling out. Sorry. So the problems exist, right? Slow queries and performance are different problems. Lots of complexity. If you look at the SQL Server installations, after you start your database, you have to maintain indexes, you have to plan hashing and distributions, you have to take care about statistics, you have to watch execution plans, whether they change or not, and lots of the complex issues. So optimization is always a case. And then the pace of business is much quicker than years ago. Years ago, it was okay for you to provision a virtual machine with SQL within half a year. Today, if you have a business that provisions virtual machine in such a way, you're dead. So what is Snowflake about? The answers to those questions. Again, marketing slide. Imagine if you have a centralized and shareable databases. You deal with automatic scaling out without your intervention, and the speed as the size of your wallet. Now, imagine that you have infrastructure which you are actually have no maintenance there, and then imagine that you can deploy this solution in minutes actually. So you can start business run on the Snowflake platform in minutes. Now, this is the architecture of enterprise data warehouse as you know it probably from the on-prem and from some cloud solutions. Typically, what are the challenges here? The first challenge is like here. You all know stories about Lambda architecture, where batch loading is quite divided from the pipelines that have to deliver data more often than once a day. So if you have real-time analytics on your mind, typically this is divided between data warehouse and some solution. I'm not sure. NoSQL databases, maybe data lake, whatever. Another problem is that whenever you create data marts or any other a format of data that you have to share with users, there's lots of complexity, and actually this can create additional projects for you. Another problem is how to easily and quickly deliver current form of your data warehouse database to test dev environments or create those environments. Typically, you have to multiply your installation in Azure, AWS, whatever you have there, just to hold those environments. So there are lots of problems. And I'm not saying Snowflake is the solution, but you may at least try it. Because it seems that you can provide both batch loading and real-time analytics with Snowflake. You can easily share data. You can easily provision your test and dev environments within seconds. You will probably see it. Now, the first difference between Snowflake and any other traditional architecture is that Snowflake presents the third architecture, not shared disk like you have in SQL Server, not shared nothing like you have in Azure SQL Data Warehouse, but multi-cluster shared data, which means in the center of your environment there are databases. We just store the data. This is a bucket of data. And over that there is a layer of compute, which is completely divided from the storage. So you can create multiple clusters querying the same databases, right? Here you have a single cluster which can scale out, but until it ends with some limitations, and it queries the same data, right? Here there are different data warehouses, how Snowflake names it, querying the same databases, which means that the storage and the compute is completely divided, and that's probably the major change in the architecture in Snowflake. So how it works actually. Snowflake consists of 3 layers actually. It has, from the bottom, it has storage, which is very cheap. On AWS it's S3, on Azure it's Azure Blob. So it's cheap, it's even cheaper than in Azure actually, which is fantastic. Another layer over the storage, you have compute, which you can treat as a bunch of VMs. Bunch of VMs connected together into clusters, but you can have multiple clusters connected to the same data, right? On the other hand, you have the third layer, which is cloud services for query optimization, management, warehouse management. So all the operations that you perform on metadata, actually they don't get here, even they don't get to compute layer. So you can expect when you, for example, create a new warehouse or create new database, or even check row count in your table, you may expect that this one and this one is not involved at all. And that means that you are not spending your money. So the process is like this. If you create anything, data warehouse, database, DDL is processed and sent from compute layer to the metadata store, which is stored on this storage. But that's all, right? If you send any query, you have nodes which can be multiplied by any number of warehouses. The number of warehouses is limited just by your wallet again. So you have money, you can create lots of warehouses and never have the problem with concurrency. I believe there is a case study of Snowflake with 3,000 concurrent users or something like that. So imagine that. Yeah. Now, the nodes, of course, are based on at some point on an MPP infrastructure. So they have their own storage, SSDs, which are primarily for one layer of caching, right? So if you look at the storage, this is the primary storage where everything is stored as your database lives, right? Here is the first layer of caching, which is not that fast as the result set caching which resides here in the cloud services layer. Now, besides that, so you can create multiple data warehouses, one for ETL, one for example, marketing, one for sales management, whatever. And you can serve different reports, for example, through different warehouses. But that's not all, because you can also spread a single cluster into many nodes, so you can scale out this cluster. So this is actually a matrix of virtual machines, which means that whenever I have a problem with scalability in terms of the number of users, number of queries, I can say to Snowflake, please scale my cluster automatically and create more nodes of the cluster. The maximum number of nodes is probably 8, as far as I remember, but you can different sizes of data warehouses, so you can, by scaling up with different sizes, like small, medium, large, you can scale up and achieve performance, while with scaling out, you can create space for serving much more queries than before. Okay, I'm going to present a demo in a moment. Now, so let's just summarize this first part. You can create multiple databases in your Snowflake instance, just like in SQL Server. Imagine in SQL Server instance with many databases, Snowflake can do it. You can create many different size data warehouses, which are clusters that can spread and that can multiply in terms of nodes. You can choose whether you perform your ETL operations with the smallest one, warehouse, and so forth. There are a bunch of partners dealing with ETL processes, and some of them, like Matillion, for example, they have dedicated tools for bringing data to Snowflake. So if you consider Snowflake as at some point startup, it's not anymore, because there are businesses that rise on top of Snowflake and that engage as partners, right? There are also a bunch of probably leading BI tools to connect to data warehouses. Power BI is one of them. So I will show you some of the Power BI reports connecting to Snowflake in the very last moment of this session, probably. And there are also lots of different solutions, different services working with Snowflake, thanks to drivers and connectors available on the market. Now, so scaling up is here. You can scale in a second. I will show you. Now, let me get through the demo one. So this is Snowflake. It's the web interface, and the very first thing that I have to show you is the entities. So you have warehouses. In this case, I have 3 warehouses. Every single of them is suspended, so I'm not paying money for the compute layer. It's definitely the most expensive part of Snowflake, if you consider for what you're going to pay. I will start some of them in a second, but you can see that easily I can, for example, select one of the warehouses and configure it into a different size. Yeah, credit typically means something between $3 and $4 if you consider pricing. I will get back to this. So you can define size, maximum number of clusters. So for scaling out, you have options from 1 to 8. You can say scaling policy, which is standard, or economy. Economy means that it will scale out a bit later. So it will wait until the concurrency reaches some bigger limit. And you can also turn on auto suspend option, which means that if this warehouse is not queried for 5 minutes, it will just suspend automatically. Just like Databricks, if you have any comparison to Microsoft services. And auto resume on the first query that steps in. And to show you how quickly it resumes. Yeah? Compare it to pausing and unpausing any service in Azure, for example. Right? And I will suspend that as well to show you how quickly it suspends. Right? And the billing is per second. So that matters. Right? But actually, the minimum amount of time billed is 1 minute. So if you're able to suspend after several seconds, you're going to pay not much. Just to give you a clue, while I was preparing to this session, I used 7 to 9 credits probably, so $36. It's not very expensive session probably. I have 400 credits. Thank you, Thomas. Now, so data warehouses. If you're about to create one, the configuration is just the same, and the SQL code shows up here if you give a name. So the code I will show you later about is just create warehouse statement, which is not very complex. Now, their databases. As I mentioned, this is just like the instance of SQL Server. You can host multiple databases in a single instance of Snowflake. These databases that you see here are actually not all of those databases are typical databases. Some of them are shared, which means that Snowflake shared with us some sample databases. This is the first one, Snowflake sample data, which provides you with TPCH benchmarking test data, so you can test your queries immediately on billions of rows, and I will show you that as well. Now, let me switch back to worksheets, and I will try to show you the first demo. So, do you see the screen? That's my first question. Do you see the letters, or should I scale it up? I know. Let me try it again. Now, is it better? I'm trying to be as productive as I can. So let me just show you quickly some of the code in Snowflake. So unfortunately, I have to click on the button. So I will have to escape that. So first one, use warehouse. If you look here in the right corner, I'm connected as one of the accounts, one of the users, which is in the sysadmin row. It's going to use compute warehouse, which is now suspended. I'm going to use some database. I'm not sure which one, but I'm going to use one. And I'm going to use some of the default schema. So there are defaults in your session. Warehouse, database, and schema, but also you can use names, full part names, like in SQL Server. You will see both things. So first of all, let me use compute WH, which is here. It should start now. Sorry, it's not starting. It's just the metadata information. I will use. I just will use this one. Probably will work. Okay, so this query is going to run on my SQL, on my compute warehouse 1, and query my own created view, which is just an util showing me how many credits I have left. So I have 390 credits left before this session. I will check. I will get back to that. So we will see what was the price of this session actually. Now. I can switch roles as well. This is important because account admin, for example, is the only role that originally can see the billing. Well, it's confusing because I just showed you the credits left. So how come? Well, you can do some workarounds to produce insights for sysadmins as well, how many credits you have left, but I will leave that without any codes. Now, I will create another warehouse which will be used by me in these demos. Demo WH DCPL, especially for you. X small, economy, maximum number of clusters 2. It's done. And I will use this warehouse for my further purpose of demo. Now I will create a database. No files, no logs, beautiful area. No stress, right? No stats, no indices. Now, I will use this database as well, and I will use schema public, which is, let's be honest, this is the synonym of DBO probably, or public. Sorry, public. Now, you can check what are the current defaults. So you can see that I'm in this database. I'm using this data warehouse with this schema. I can also use 4 part names, and I will show you this with my data warehouse suspended. So I'm suspending the data warehouse that I was using a second ago, and I'm getting to database called Snowflake sample data schema tpch blah 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 orders, and I'm going to describe this table. Metadata operation, my warehouse is still suspended. Yeah, okay. Now let's see how many rows we have in this orders table. What do you think? It's also a metadata operation. My warehouse is still suspended. Now, let's check some things about the performance. I will change the warehouse to some bigger warehouse, compute WH2, which is M-sized. And I will run some query. This query is not very, it's not a very complex query. It's taken from tpch benchmark. So I will just run it. I will give it a chance. Run. And while this query is running, whoa, I was cached. It was cached. My demo just exploded. That was the result set cache. If you, oh sorry, was it failed? No. If you look at the query ID, click on the history, and see in the profile, and there was nothing actually. It was taken directly from results set cache, because I executed this query previously, exactly the same query. So let me change this query a bit just to make it a bit different. So you will see maybe this one, okay, and run it again. This is definitely not the same query, so this will take some time. I'm not sure how long it will take. M-sized, maximum 2 nodes, 30 seconds, maybe 40. I'm not sure. Maybe more. If it doesn't end in let's say 10 seconds, I will abort it. So I will just show you how scaling up, not out, but up, can speed up the queries. Let's give it like 45, and I will abort it. It should, at some point, it should end like within a minute or something. Okay, so it's not very efficient, right? So let's move on and immediately resize this warehouse. Let's take 2x. How about that? So right now, I'm having 2x compute WH warehouse. It's risky operation. Didn't test that. This is a completely new query. It can be much more sophisticated, but it takes for 14 or 15 seconds. If you change to something bigger, let's move on 3 times. Oh, sorry. Does it mean anything to Snowflake at the moment? How long this will take? This is caching, right? So I'm sorry, but I'm going to size down to medium. But you see that scaling up is for gaining performance. Yeah, I know. So far with SQL Server, we learned that well, yeah, hardware is the last one to upgrade. This can change a bit, right? Because you're not using any indexes, any additional things, but just scaling up the warehouse, which is still one node warehouse actually. Now, let me show you another demo on scalability. I will run some script, which is very basic. It runs the same SQL script 32 times. You might guess what happens. I'm creating a situation when I have 32 users querying Snowflake with the same data warehouse. Now, to show you the query is not very sophisticated, but I will show you that. It's not going to use the cache. Why? Or at least it will use cache slightly, because I'm going to randomize parameters of the query. So it will aggregate the data for years and months and do some fancy stuff just to generate random queries, right? So I'm not doing any caching here. And what I'm going to show you is how this is happening in terms of scaling out. So I'm going to run this now. Lots of windows should open. Yeah, that was expected. Still opening. That's amusing, but I will suffer this again. Hit me again. Oh my God. That was the easiest way to mimic that. My warehouse is actually, well, it should scale in a second, but still the windows are starting. I'm sure it's scale. I have auto refresh enabled. You can observe this second, to active. You see that? After some time, after some number of sessions started, and the cloud services layer observed that, okay, we see that the concurrency is too big for a single node. It created another. It's actually just added another node within a second, and you can have 2, 3, up to 4. This one is going to scale up to 4. So 3, yeah, actually it needed 3 nodes to serve these queries. What does it mean actually? It means that you can create a cluster which responds to your peaks of workloads immediately, and as well you can start another cluster immediately. Just reconnect your reports or queries to another data warehouse, and you're done. Because the compute warehouses are completely separated from each other in terms of computing power. So you can use 1, 2, 3, 11 warehouses. I'm happy to see Clouds on Mars here. You have 11 warehouses, right? In one of the customers. I know it. 11. 11 warehouses. You can start 11 warehouses to serve tens of users. And then just pause if you don't need any of those warehouses. So, yeah, that's how scaling out works actually. Now, let's move on to data loading. You create something called stage, which can be attached to Snowflake, and it depends on which cloud platform you create your Snowflake instance. Then it creates S3 or Azure Blob Storage in itself, but you can also connect to existing blob storage if you have it in Azure. So you can just run your data loading directly to your blob storage which you have in your infrastructure. And the loading is fairly simple. You can use one statement copy into, which just does the thing. And also, here is very simple data loading from stage. But also you can manipulate data on the way. So you can put parentheses here, write some select statements, do some transformations on the way, which is not a very popular method, but you can do that. You're not limited to just pumping data in Snowflake. So typical architecture in Azure can look like this. You can have blob storage which can serve as a stage for external stage for blob storage. This is live, sorry, not today. The connector is on the way probably, so you will be able to connect to Data Lake Store Gen 2 in several months, I'm not sure. But also you can use things like Event Hub to provide things around streaming and real-time analytics to Snowflake. Snowflake has its own mechanism called Snowpipe. I'm not going to show you Snowpipe today, but just make sure that you read about it, because this supports real-time analytics in terms of getting data more frequently than on a batch basis. You will use Snowpipe, not copy into state. So let me just switch to demo. Sorry, fancy stuff. Oh, some of the Snowflake workloads are running, but I will switch to that. Yeah. So let me switch to some database which I created just before. Schema public. Now I have to create a stage. Stages are connected directly to databases. So I'm getting into my database, into Stages tab, and I'm going to create a stage. I'm going to use existing Microsoft Azure location. You see the very easy interface, which just leads you through all the steps which is necessary to point where you store your staging data. So yes, I'm going to use existing Azure Blob Storage location, right? Next, demo stage DCPL. Now I have to take my snippets. Try not to memorize my SAS. This will be probably recorded, so you will take your time. Now, so here is my URL to my container and some path that contains files. And also I will use SAS, which fortunately should give me access. I hope so. If I remember well, it's until the end of September. And that's it. If you want to create it with SQL, you can use SQL, but I just created manually. Now, so I can describe the stage. If everything goes okay, you can see that this stage is created. Now, I will use this warehouse, and I will create a table within my demo db-dcpl database in public schema, table called trips. Okay. You can describe this table. See its columns. You can also query information schema views known from the SQL standard. Now I will show you that it contains no rows, and I will try to load all the files that are in this particular city bikes path in the Azure Blob Storage. But before I do that, I will create another thing, which is file format. If you work with Azure SQL Data Warehouse, you may know that. You also can load the data without having file format, and I will show you the code later on. So I will just create demo format DCPL, which is public CSV compression method. Well, none probably, comma. I have a header within my files, so one. It's double quote, which is a separator of strings, and probably that's it. So let me check if I have luck and my gods are with me. If I have an empty table, sorry, why is that? Okay, this is something which is a surprise for me. Let me see what I have in my storage. Whoa. No, it's not credits. I'm out of luck. Okay, should work. Probably the path is wrong, but let me just try it. City bike, yeah, it's here. So I probably have some errors with my definition of stage.
if it doesn't work, I will just use another code to import this data. Edit city bike probably. Just let me check it. Sure, city bike. Always before you copy the data, you can check. You can check the. Sorry. You can check the stage. You can list the files, but this time it should work. I hope so. So with a couple of seconds, under 10 seconds, I have 3 files loaded with slightly above 2.5 million rows imported. So I can validate immediately my load to see whether there were errors, important for your ETL audits. I can also see a history of all imports for a specific table or for any table in history, and yeah, and the load for the single table as well. This is the code that may serve you as a replacement for creating file format and stage. You just take the stage and then file format. You just enter explicitly. But this is not my case. So I have 2.5 million rows, something like this. Now I can play with SQL. For example, I can see which weekdays were the most heavily bike ridden, and it seems that Saturday and Sunday, 0 and 6, had slightly higher trip duration. Now you can also use some sophisticated functions like hover-seen. It's just a calculation of distance based off latitude and longitude. Well, pretty much simple. So you have latitude, longitude, and you calculate how many kilometers the ride took, right? And it just returns the result. So that was ETL part. It was pretty easy, I know. Continuous loading, I will leave to you. Use SnowPipe, use some Azure services to support it. Now, sorry. So there are some unique features related to Snowflake. First of all, you can serve easily unstructured data. And by unstructured, I mean typical formats: XML, JSON, ORC, Avro, and Parquet. All of them. So they can be stored within your Snowflake database. There are 3 types which can store, let's say, non-relational data. Variant is one, 16 megabytes of just blob data, which can be JSON, which can be ORC, whatever. Then you can have object, which is key value pair based, and then you can have also array, which is just an array. Okay? How to minimize this thing? Okay. Now you can clone your databases and tables within a single database by just running clone create clone statement. So this is zero copy cloning, which means that if you have a terabyte database, you can clone it, for example, for test and dev environment in a couple of seconds. No backups, no things, no, just magic, right? If you compare it to SQL Server, database snapshots can be something like that. Okay? So you just collect the differences between the clone database and the original database, right? And you can just create another DevOps data warehouse, and you have scenario of DevOps test dev environment served. You can also use time travel, which is pretty much interesting. I will show you that in a moment, but you can do everything. You can do mistakes. You can delete your data, you can delete your tables, databases. You can delete data, you can get back this data without any backups and things. It just works. It's turned on by default.
right? So let's start with time travel. This is the life cycle of data in Snowflake. You create databases, tables, insert data by copying or inserting. You select data, but you can use select from at or before any point of time, any interval back in time, and before or at any statement by ID of query. Beautiful. This is beautiful. I love it. You can by accident delete some portion of data in your fact table and bring it back by selecting that like a charm, right? Also, you can create a clone of your database by cloning its seconds. Its seconds can create a clone in time or in this time. If you omit this part, you will clone the database as it is in this second, right? Then you can undrop table. Yay! You drop table, you undrop table, and there is your table. Easy. No maintenance. Keywords. Timestamp, offset, and statement. Those three keywords are used with at and before clauses, right? That's magic. Now, semi-structured data. I mentioned that there are three types of data. Variant is probably the most popular. 5 data formats. Flatten function, just like in Spark, probably. Lateral joins, just like in Spark, probably. So you may see big data elements here. I will show you a demo in a second. Now, secure data sharing. Imagine that you have a company that also runs Snowflake, or it doesn't run Snowflake. You can share data within another Snowflake instance, your database, in seconds. You just create a share, a secure data share. You provide, let's say, a role for accessing this share, and if anyone has their own Snowflake instance, or they don't have their own instance, but you create a reader instance for them, you can consume this data just minute later. Now, I will not focus on the slides because slides are boring probably. Now, security. You will ask for security. Some people raise the point that Snowflake has no RLS. Yeah, it doesn't have RLS, but it has actually features that allow you to implement RLS on your own. You have current user function which serves well. you just add additional table that solves the problem, just like with your tabular installations, right? You can create dynamic row level security using some part of modeling of your warehouse as well with together with functions. But to provide access, you have roles. There are four default roles: account admin, sysadmin, public, and security admin. But you can create your own. You can also provide imported permissions, which, for example, can serve you as giving permissions to originally hidden Snowflake database, where all the historical data, all the billing data can be accessed. You can also base on just regular access control by permissions. Grant and revoke statements are there. Encrypted data, they are encrypted at rest all the time. There's no magical switch to turn it on, nothing like that. You can also use cloud HSM systems to store your keys, right? Failsafe. With Failsafe, you're 7 days good with deleting your things after the time travel period ends, which can be as long as 90 days for enterprise additional, I think. Okay, so now let me show you some quick demos on those unique features. So let's start with time travel. I'm moving to my warehouse demo WHDCPL using my database public. Okay, so first of all, I have 2.5 million rows in my trips table. So let's delete something. I'm deleting some rows. Boom. Over 5
500,000 rows deleted, but 3 minutes ago I was good. So to give you a clue, I will try to find it out. Now this interval, offset minus 60 seconds multiplied by 3. I'm getting back to my history 180 seconds ago. I hope so. I was that time. Boom. Yeah, I was good then. 2.5 million rows, right? Or I could use statement, but I don't have any query ID. This is historical query ID, so I'm not going to run this. So now I can even truncate my table and do as easy thing as insert into my trips table from historical version of trips table 3 minutes ago. And I'm still good. I have my 2.5 million rows. So now I will drop my table, just like SQL injection does sometimes. And then you see, yeah, the errors just shows up, but I can undrop my table to have it back. And you can see that I have my rows back in the table. So now this is something like time travel. Also cloning, I mentioned, keyword clone. I clone my table, and I create a clone which takes no storage underneath, and I can query this table, play with that, delete rows. It's completely separated from the original table. And the same you can do with databases, which is even more practical, because this goes that you can easily create environments. Just add another clone of database, another data warehouse, and you have another environment working. Seconds. Now, semi-structured data. Yeah, this is the only moment I'm using AWS probably, but I have some demo data in S3 storage. So let me list this newly created stage. It contains some files with JSON data. So I will show you. I will create a table and I will copy this JSON content into my table. So I have a single column of variant type, and I will show you the rows. So the rows are just pure JSON. I can click on that, and I will see the code of JSON format. Yeah, this is something typically stored within JSON. So it's a complex data type, as everybody knows. So how to deal with that? I can create a SQL code which will use this one. It will take my v column, city part of my JSON, name part of the city part, and put it into string column, right? As easy as that. So this view actually unpacks JSON, flattens it in the very simple way. This is a manual job, but you can do much more. So I can now use my view and see some data which is completely relational right now. So I unpack this JSON into a table actually. But also I can do things like yeah, so I use this weather data to join it with trips, and I will show you in which weather conditions the trips were, what was the number of trips, and yeah, you see that people in New York travel mostly in clear weather and clouds, nothing very sophisticated. But also, you can do some things further. I will use Google Analytics file to show you some real-life example. So now I have no rows, but I will try to put some of the data. And this is also some beauty parts of your development environments. You can take your table, Google Analytics. I hope it works. Some lag here. The end of internet or something. Okay, Google Analytics. And now you see load table. And I can choose, well, yeah, compute WH maybe. Next. select files, and I will just select Google Analytics file, JSON file from my laptop, and I will use a format which I'll create on the fly, which will be called demo JSON format, DCPL maybe, and I will use JSON, and probably that's it. And I will load this data, hopefully. And that's it. So now I should have some Google Analytics data in JSON stored in my Snowflake, and I can deal with it to make it more relational with, for example, lateral flatten, which will flatten my heats area. There is a bunch of information about heats. Which browser was used by the user, what was the version of browser. So if you have e-commerce scenario, this is typical query. So I will check date, hour, and things around heats, right? How many heats were per date and per hour. And it just shows me that the most heats I had on this date at 9 o'clock. That's it. So as quick as that. Now, secure data sharing, I will omit that because the time is flying so fast. Yeah, the code I will show you here, or maybe no, I will not omit that. Let me just fire this at whole, and so this creates a share of my demo DB DCPL database, and I will add another account of Snowflake. Oh my God, I have 2 accounts. So I have 800 credits actually. Okay, it's done. Now I will show you grants of this share, and it should be empty. Well, okay. Now let's do the following. Let's start another tab, and I will move to another Snowflake environment. As you may expect, this is the consumer of my shared data. I will just log in. Everyone knows this. Oh yeah, where's my phone? This is multi-factor authentication. Actually, I was about to show you that. So yeah, I have my approval here. Thank you. And now I should see in Shares tab, whenever I switch to account admin role, probably. Come on. Yeah, share DCPL. See here? And I can immediately, with a link, create a database from this share. Name it test, whatever. And I have access to the data stored within different Snowflake environments. Just like file share, maybe. Cool. Now, let's do some SQL. Actually, I was looking for some meaningful differences between T-SQL and SQL available in Snowflake. Basically, it's mostly SQL 99, but not in every single place. So I just put some interesting stuff, or maybe this something that can be discussive. So, multi-table insert. You can decide on the fly how to spread your rows from a single table into multiple tables, both in insert and merge statements. Very nasty thing. If you implement Data Vault, that can be a game changer with your satellites, especially when you have frequency-based satellites. You can have transient tables, so you can turn off time travel for a table, not consume your storage, which is cheap, but you may not have all the tables with requirement of storing historical versions of data. You can have materialized views. Michał can confirm this can take your money. If you rebuild this, or if it rebuilds automatically, it will take your credits, so be careful. You have aggregation functions. I have no example here, but if you deal with problems like really nasty distinct count calculations, that can serve well. There is a HR accumulate functions or something like that that can easy this thing. This is estimating things, but if you're not relying on 100% precise measures, that will be okay. So it has some percentage of mistake. Unfortunately, stored procedures are written in JavaScript. This is very controversial thing for me because so far Snowflake may look like a very user-friendly platform. Well, if you're a developer and you want to deliver procedural code, learn JavaScript immediately. Or maybe ask guys from Snowflake whether they are going to implement SQL-based procedures. Because now it feels like you're forced to write every single procedure in a dynamic SQL way, a bit. You have recursive CTE, but you can also use connect by, which is pretty much new statement. I believe it was announced like a month ago or something. So I will show you that. It's pretty smart. You have collation support. By default, Snowflake stores data, all the data in the UTF-8 format. And actually, if you get your interest in data types, it uses micro-partitioning stuff, which is a very powerful thing. It's actually Polish. It's actually Polish. What's the name for Venazek? Invention. The guy from Białystok, which is like one of the co-founders of Snowflake, Marcin Żukowski. Thank you. Marcin Żukowski invented a thing called micro-partitioning, which is actually the whole storage layer for Snowflake. That's the reason why you don't have indexes, why you don't deal with any, I'm not sure, rebuilding whatever you have there. It just works, right? Because it's patented technology underneath it. Now, about collations and data types. UTF-8, that's the default code page for varchars and all the text stuff. But also you can have collation support with all the different collations. It's urgent if you have if you have to change sorting requirements, right? You have to sort by Polish letters, for example. Now you have data generation functions. For example, table generator row count 10. It's like you in SQL Server join to a table of numbers with 10 rows. Simple and very powerful. So you can select from this table and it will produce 10 rows with your own content, right? So very cool. Now let me show you some of the things. Sorry, worksheets, queries. Come on. I know you can work. Oh no. This is not the one. Yeah. Okay. Sorry about that. This will not take long, probably. So I have my DCPL, public. Yeah. Okay. So I will create another table, trips something, and I will also create a table like trips, which is an empty table based on the schema of trips table. Very smart. Empty table, just with the same structure. Both tables are empty, 0 rows. Just to confirm, 0. Okay. Now, this is the multi-insert statement. You see that? Insert all. Insert all columns when I see month 1, January, or month 2, select different tables. Nice. Single statement. Should work. So you can see some number of rows just went to one table, some to another. Everything works. Now, stored procedures. Now this is nasty part. I'm not going to spend more time because I'm not JavaScript expert. So I just wrote very basic thing. I'm taking a single column start station name, doing a count, and checking which stations, which starting stations were the most popular, and I concatenate 3 top stations to show you on the screen. So basic code, but it doesn't have any SQL injection weaknesses because I'm not having any parameters. So basically, if you learn JavaScript, you're in the right planet. So it's not very sophisticated. You create statement, you execute it, you collect the result set, which can serve as a cursor. Yeah, you can use next. This is a cursor actually. So I take my 3 rows, stepping into another one, and collecting all the names into one value. So if I call it, call is another statement for just executing stored procedures. I have top 3 start stations at the bottom of the screen. Now, connect by. You have a typical challenge how to manage hierarchical data, so employee, manager, things like that. I have some rows. President has no bosses, and other guys are just below the president. So I can use connect by. Instead of dealing with CTE and complex things, I can use just connect, start with title president, and just go down. And also, you can use this function sysconnect by path, which will produce what normally path item or some functions in DAX produce. President, vice president. Pretty neat. I think it's good. Now, cost management is a bit tricky. Not everything is documented. That's also something Gartner mentions. Yeah, that's your bad thing, because you know how much you're paying for your warehouses. That's even on the pricing page. You see how many credits is per hour per each data warehouse of the size X. The billing is per second with minimum of 60 seconds. So it's quite nice. You can use account button to enter billing details, which are shown in a fancy report way, but you can also build your own report. And I have one with Power BI, of course, but because you can use historical views or tables stored within account usage schema of Snowflake database. So if you have access to Snowflake database, which is hidden, or at least it's not accessible for anyone besides account admin, you can see those tables, build views on top of that, and serve the data to the Power BI report. So let me show you that. Yeah, that's my report actually. It's in import mode. It's very basic, but it shows me that until this morning I had 9 credits consumed with 33 hours of working. This is September only. I had some meaningless consumption in August as well. You can see when I was testing my demos the most, I was today, but I worked on that for a couple of days. I can actually refresh the data to see whether I consumed a lot. We should see the difference. Wonder how much. I'm using one of the XS data warehouses to access the data. What I had to do before, I installed ODBC driver. No changes?
33 and 37.
But no differences in credits. That's weird. That's weird. Actually, okay. So I'm not sure if this is the right number. So let me switch to code. I believe code more, and I will just put you in my cost management demo. So I will share the views I actually created. So this is the view that takes Snowflake account usage warehouse metering history, which takes compute cost, And below is the view based on Snowflake account usage, storage usage, which takes the storage consumed by Snowflake. It's not the cost actually. So you have to calculate it on your own based on the pricing of the storage, but it's actually it's minor. If you compute, if you compare it to compute, it's minor. So let me show you the numbers. Actually, yeah, let me see storage. So you can see actually the storage is not very big. I consumed, well, something like, it's in gigabytes, so 300 megs probably, 400 maybe, something like that. And in terms of credits left, that should be something different. Well, actually, 390. Whoa, I was running 3XL for a second. I was lucky probably. I didn't reach 1 minute. So I will see that later on if I use the same sizing, but not now. So you can see that there was cheap demo actually. Yeah, that was cool. Now, editions and pricing. What you saw today was the enterprise edition, because that's the trial. There are actually two higher editions. In Azure, you have also enterprise for sensitive data, where some additional certificates of security are fulfilled, like HIPAA or something like that, PCI. So if you're financial, if you're storing health data, probably you should go into this direction. But if you're just commercial, enterprise should be good. Remember, all the data are encrypted in the Snowflake databases by default, right? $3.70 is the price for the credit, right? And then you have to check how many credits it costs to run your data warehouses. But it's pretty much easy. XS costs 1 credit per hour. S costs twice as that, and it just multiplies by 2. Right? So easy calculation. Now, if you're working with Azure, 6 regions are available for you, with this one actually available for 2 days actually. And I was creating this instance, Southeast Asia, which means Singapore was not there. I think the pace of in development of Snowflake is pretty much the same as Power BI. Every single month we see something new. I'm using West Europe in most cases. Probably will use also East US in a moment, but that's a matter of discussion. In AWS, you also have VPS, which means isolated instance of Snowflake. So we are waiting for actually this edition in Azure, because that would mean that Snowflake will fly in Marketplace. So you will be able to store Snowflake installation within your own subscription. As of today, you have Snowflake somewhere else. It can still be in your region, West Europe, for example, but it's not in your subscription, which can be a mind blocker for some companies. Now, how to learn this thing? I'm still learning, so I will just give you my steps. First, start a trial. Pro tip here: delete the default compute warehouse because it's large or X large. Do not play with that. Just create XS for your starting point. Run hands-on lab. There's a good hands-on lab which shows step by step how to use Snowflake features. So to learn basics is good enough. But you can have also some videos before you start actually playing with Snowflake. Watch videos with Snowflake features, and I believe there are some demos as well. You just go to playlists and see something meaningful for you. Now, Snowflake's blog is also interesting. You can see, for example, some samples of how to generate data for your test environments. But I think PPCH data is more than enough for you to test, because you can have tables with hundreds, billions of rows. Now, tutorials, videos, other resources on the Snowflake in Snowflake documentation is also something to access, and also materials from this
this simple presentation is available on GitHub, so you can just download it from this resource. Now, yeah, this is the only one Polish accent here. So thank you for coming to my session. Again, I'm one of the Elitmind's crew members, CTO. If you have questions or you want to work with us, just drop me an email. But also you have Snowflake's representatives too, yeah, Tomasz and Piotr. So you can ask them more sophisticated questions like why this thing is so cheap. So with that, the only one thing I have to say is that there is a PaaS Summit on the way. It's not Snowflake event, but it's Microsoft related event hosted in Seattle in November. So 5th to 8th November. If you want to meet people from the community worldwide and guys from Azure, SQL Server, and Power BI product groups, that's the place you can visit. I'm going to be there, so I'm just sharing the news. You can also watch next week 24 Hours of PaaS. They will present content preview of PaaS Summit, so you may make sure that it's worth of your money because it costs some money. I believe Hubert can grab some discounts, but only for members of VCPS. So if you're a member, ask Hubert. You can have some vouchers or something. Yeah. So with that, again, thank you, and I hope you enjoyed the session. If you have questions, I'm.
And we got a short break to